Good day, everyone. I'm Mr. Joseph, your chemistry teacher. Today's lesson is a continuation of our previous, lesson, and we're still on the topic, the mole concept. From our previous class, we learned that the mole is the standard unit of amount. It is what contains the various number of particles, which is 6.02 times 10 raised by 23 atoms, molecules, or ions. I think we're able to state the relation between mole and the relative atomic masses of elements and relative molecular masses of compounds. Now, 1 mole of any substance is equal to the relative atomic mass of that substance if it's an element, or the relative molecular mass of that substance if it is what, if it is a compound. And we took time to explain it in our previous class. You can go back and watch the video. And we also stated the relationship between the number of mole, the mass, and the molar mass or the atomic mass. We're meant to understand that the number of mole is equal to what? Mass over what? Molar mass if it's a compound, or it can be number of mole is equal to mass over relative atomic mass if it's an element. So from this we can calculate the mass. Mass now be equal to the number of moles times the molar mass. The molar mass is the mass of 1 mole of that substance. 1 mole of a compound is the molar mass. Or we can say mass is equal to the number of moles times atomic mass. So from our previous class, we also solved calculations on moles involving reactive masses. We use a particular approach. Today I'll be using a different approach. I'm using a different method, whichever one is you're comfortable with. Please feel free to use it, because at the end of the day you arrive at the same answer. So that is it. Today we're going to be relating the moles of the reactant to that of the product. In our last calculation, we were able to relate the masses of what each of the reactant and the product we are asked to look for. So today we'll be using a different approach entirely. So let me bring that the question. Then we see. So for our last class, this was the question we solved, and today we're going to use a different approach to this. So let's proceed. First of all, we'll look at the question. The strontium letter can be extracted from strontium oxide, SRO, by reduction with aluminum. One of the possible reactions is shown. 6 moles of strontium oxide react to 2 moles of aluminum, which is the reactant, to produce 3 moles of strontium and 1 mole of strontium aluminum oxide. So what is the maximum mass of strontium metal that can be produced from the reduction of 100 grams of strontium? So the first thing we look at, we check the equation of the reaction if it is balanced. From all indication, you can see that the equation is balanced. We have 6 moles of strontium on the reactant, 6 atoms of strontium on the reactant, and 6 atoms of strontium on the product. 6 atoms of oxygen on the reactant, the same 6 atoms of oxygen on the product, 2 atoms of aluminum on the reactant, 2 atoms of aluminum on the product. For a reaction to be balanced, for an equation to be balanced, the number of atoms of each of the elements in the reactant must be equal to the number of atoms of each of the elements on the product. So from all indication, you discover that the equation is what? Balanced. Then you now focus on what you are asked to calculate. They say what is the maximum mass of strontium metal that can be produced from the reduction of 100 grams of strontium oxide using this reaction. So what we're going to do here is that we're going to focus on, the reactant and the product we have to calculate. So from this, you discover that we'll focus on what? Strontium oxide and strontium metal. So that will not be distracted by, the other reactant and other product. So now, if you look at the reactant, we have 6 moles of strontium oxide and 3 moles of strontium. They say what is the maximum mass of strontium that can be produced from 100 grams? So using our formula, number of moles is equal to what? Mass over what? Over the molar mass. So we're going to calculate the number of moles of strontium oxide. Number of moles of 100 grams of strontium oxide. Then the number of moles is mass over molar mass. So the mass of strontium oxide is 100. Then we're going to calculate the molar mass of strontium oxide, which is the mass of 1 mole of strontium oxide. That is the molar mass. So look at our periodic table. From our periodic table, strontium, the relative atomic mass of strontium is 87.6, and the relative atomic mass of oxygen is 16. So we'll add the two to give us, so 87.6. I'm going to use my calculator now. 87.6 plus what? 16. So by the time you add the two, 87.6 plus 16, you'll be getting 103.6, which is the molar mass of strontium oxide, 103.6. So to get the number of moles of strontium oxide, 100 divided by 103.6, you get 0.965 moles of strontium oxide. Moles of strontium oxide. So now we'll proceed. Now, if you look at the calculation, if you look at the equation states that 6 moles of what? Of strontium oxide reacts to give you 3 moles of strontium. Therefore, 0.965 moles of strontium oxide will give you what mass of strontium? What moles of strontium? Then you cross multiply. So it will now be 3 times what? 0.965 divided by 6. So you get what? 3 times 0.965 divided by 6. It will be what? 0.483 moles of strontium. 0.483 moles of strontium. That's what you're going to get. So now we have to calculate what is the maximum mass of the strontium metal. So since we've gotten the number of moles of strontium, so what we have to do is what? Number of moles is equal to what? Mass over what? Molar mass. So if we cross multiply, the mass now will be equal to what? Number of mole times what? Molar mass. So the mass of strontium, that 100 grams of strontium that we produce, will be equal to, what's the number of mole? 0.483 multiplied by the relative atomic mass of what? Strontium. So we can use relative atomic mass here instead of using molar mass. I can just put relative atomic mass, which is what? AR, relative atomic mass, since we are dealing with strontium, which is what? An element. So I can put relative atomic mass here. I can also do the same here. So the relative atomic mass of strontium is 87.1, 87.6. So multiply by what? 87.6 and 6. So the mass will be equal to, so I'm to use my calculator, 0.483 multiplied by 87.6. So the answer will be what? 42 point what? 27 gram, which is approximately 42.3 gram. Therefore, the answer to this question is what? B, which is 42.3 gram. So it's a simpler approach. You can use it, or you can use the previous approach. At the end of the day, you arrive at the same work and the same answer. So just concentrate on what you're asked to calculate, which is the mass of the reactant and also the product. So relate it. What is the mass of strontium oxide that can be produced? What are the mass of strontium that you can get from 100 grams of strontium oxide? So just focus on what you are asked to calculate and you get the answer. So I think it's a very simple approach. Just feel free and solve as many questions as possible. I'll give you one particular question as an assignment. Please work on it. And feel free to contact me if you experience any difficulty. You can go to the comment section and put down your comment, and I'll be glad to reach out to you. So I think I'll give you one as an assignment to solve. Yes. So this is your assignment. You are getting the same approach. So please, I want you to solve this. I'll just allow it for some time so that you can take it down. So you can use both approach, and at the end of the day, you arrive at the same answer. Thank you for listening. And please, I want you to watch. I want you to comment. I want you to share. I want you to like. Thank you very much. I'm Mr. Joseph, your chemistry teacher. So feel free to contact me with this any challenge.